Okay guys, we're still talking about how to do systems of equations using matrices. And when we talk about systems of equations, what's the easiest thing? Like, what did we learn in Algebra 2?
Substitution and elimination.
Yeah, and typically it was for how many equations?
Two equations, two unknowns.
Yeah, two equations, two unknowns. You just do substitution, elimination, one of those things. Very quickly you can get to a solution. But by the time you get to three equations and three unknowns, it's hard to do it that way. And if you have 5 or 10 or 20 equations and 20 unknowns, it's very hard to work it. So we learned using Gaussian elimination. To do Gaussian elimination, you take your equations, you put the coefficients in a matrix, and then what is the key that you're trying to manipulate it to get to what form?
You want it to get to row echelon form, so you want a diagonal of ones.
Yeah, row echelon form where you have like a 1, a 0, 1, 0, 0, 1, 0, 0, 0, 1. And you manipulate it using your three rules to get it like this. Now these other ones are going to come what may. They'll just be whatever they are as you do the manipulations. There's three manipulations you can do. You can do what?
You can swap rows.
You can swap rows, okay.
You can add or subtract, like a constant of a row.
Yeah, a multiple of a row.
Of a
You
row.
can add a multiple of a row to another row, or you can subtract a multiple of a row.
And then you can multiply by a constant.
Yeah, multiply
Except for
one
zero.
row all the way across the whole row by a constant. And by doing those things, you can get it in this form, and this is row echelon form. And then what you do is, you know that like if this was like x, y, z, w, then you have 1w is equal to this, you know w, then here you would have z times this plus w times this is this. You back substitute, and then you just kind of go back to your old back substitution to work your way back up. Okay. The problem is when you work down to this point, you could do it correctly and then you could make a mistake as you were back substituting. All right. So let's say you're to this point and then you have numbers here, 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 and then this one you got, then you take this one with this one that you got, and then you figure out that one, and you kind of back substitute to get it. But if you look at this, and let's say these are all numbers in here, when you get to this point, this one is easy, you've got it. When you get to this, what do you wish was here?
A 0.
You wish that this was a 0. So then you've got to do a manipulation to make that 0. Okay? Then what do you wish these two were?
0.
0, 0, and 0, 0, 0. Okay. So the way this works is you do everything exactly the same as with Gaussian elimination, but you don't stop. Okay? So what do? You work your way down to here, and then you say, okay, now I got to make that a 0. So you do like a multiple of this row and add it to this row to get rid of that 0. Okay? And you would add it because then this one you don't want to mess up the 1, right? So you would take some multiple of this, add it to this to get 0, and you don't mess up the 1 because there's a 0 there. So you've got to come all the way down, and then you've got to go back up. Ben, does this make sense to you?
Yes.
Okay, did you get enough on the video to sort of see what we were doing?
Yes.
Okay, so what we want to do now is let's work a problem. All right? So I have x minus 2y plus 3z equals 9. Okay? I have minus x plus 3y equal minus 4. I have 2x minus 5y plus 5z equals 17. Okay, so what is the first thing I need to do here?
You need to put it in the Gauss.
You need to put it in the setup form and then
The row echelon form,
Yeah.
right? Okay, and what am I missing here? I just need to put in what?
Z.
Plus 0z. Okay, so now I can come over here and I can make my augmented matrix, right? So what would my numbers be, Ben? How do I go across the top?
Be 1,
Okay,
-2,
negative 2,
3,
3.
Cool. And then 9.
Okay. And then Emmy,
You have -1,
negative 1,
3,
3,
0,
0,
and -4.
negative 4. Okay. And then Catherine,
It'll be 2,
okay,
-5,
negative 5.
5, and 17.
Okay. So we are ready to go now. All right. So, is there any row swapping that would make sense?
No.
No, because I already have a 1 here, right?
Yes.
So for the first pass through, my first row is done. So what would I want to do to my second row?
Add row 1.
I'm going to add row 1, and then I'll get a 0 here, right? And then what do I want to do to my third row?
Add. So you
Subtract.
subtract 2 times row 1.
2 times row 1, and that'll get rid of that. Okay? So then across here I'm going to have 1, minus 2, 3, and 9. Okay? I'm going to have minus 1 plus 1 is 0, 3 minus 2 is 1. Why am I happy?
Because
Because
magic
now
happens.
you have a 1.
I got a freebie, right? I got a 1 there, which doesn't always happen. Then I have 0 plus 3 is,
3.
okay, minus 4 plus 9 is
5.
5. Okay, now here I want to subtract 2 times row 1 from row 3. So 2 minus 2 is 0. Okay, minus 5 minus 2 times minus 4, that'd be minus 5 plus 4,
It's
right?
-1.
Negative 1. Okay, and then I go 5 minus 6 is minus 1. And then I go 17 minus 18 is minus 1. Did I do that right? I believe I did.
I think so.
Ooh. Okay, why are we happy now, Ben?
Now we can add those.
Thank you, Ben.
Oh, sorry, sorry.
That's all right. I'm teasing you. Do you see that it wasn't like complete magic, but it's going to be easy. So this one is done. This one is done. What do I want to do here?
You want to add row 2.
I want to add row 2 to row 3. And so now I have 1 minus 2, 3, 9. Okay. Then I'm going to have 0, 1, 3, 5. Now I'm going to add row 2. 0 plus 0 is 0. Minus 1 plus 1 is 0. Minus 1 plus 3 is 2. And minus 1 plus 5 is 4. All right.
So
Multiply
now
that by
you
1/2.
Yeah, multiply by 1/2. So we're kind of happy. They kind of made this an easy one, right?
Yes.
So times 1/2. So now I'm going to have 1 minus 2, 3, 9, 0, 1, 3, 5, and then I'm going to multiply it by 1/2. So I'm going to have 0, 0, 1, 2. Okay, so if we were just doing Gaussian elimination, we would be done, right?
Yeah.
And in fact, we already know that if this is z, we know that 1z is 2, right? So we would know it. But now, what is it that I want to do? When you look at this, tell me in words what I want to do next.
You want to, like, go work your way back up. Like,
Yeah.
make that 3 a 0.
Yes, I
Not
want to
like
make the 3 a 0, because I'm going to work my way back up. And I want to make the 3 a 0 without
changing that.
changing that. So you could say, oh, we'll just subtract row 1 from here, but if I did that, I'm going to mess everything up. I got to work with the row beneath it.
You want to do
So minus 3 times row 3.
Yep.
Minus 3 times row 3. So row 2 is going to be row 2 minus 3 times row 3. And so here I'm going to have 1, minus 2, 3, and 9. And then I'm going to have 0 still, and a 1. And then I'm going to have 3 minus 3 times row 3 is going to make that a what?
0.
0. Okay? And then I'm going to have 5 minus 3 times 2 is going to become what?
-1.
Negative 1. And then I still have this one. 0, 0, 1, 2. Okay. Now, what do I want to deal with now?
The negative. I
do
mean-
with the top row?
The top row, right?
So you probably need to deal with the 3 first.
Okay, let's deal with the 3 first. It's kind of like, I think you could do either one.
Okay.
But to deal with the 3, I better use this row,
Well,
right?
you could deal with both of them at the same time.
How's that?
You could subtract 3 times row 3 and also add 2 times row 2.
You are correct. Okay, you are correct. I'm going to do it in 2 steps just because I
Yes, sir.
might make a mistake, but you have very, very good insight on that. So what we're going to do is let's subtract 3 times row 3. Okay? So this is going to be, row 1 is going to be, I'm going to subtract 3 times row 3. So this is still going to be 1 minus 2, and then 3 minus 3 is 0, and then 9 minus 3 times 2, 9 minus 6 is
3.
3. Okay? And then 0, 1, 0, minus 1, 0, 0, 1, 2. Okay, Catherine, what do you want me to do now?
Add 2 times row 2.
Okay, to row 2. No, 2, I'm sorry, you're right. To row 1, I'm going to add 2 times row 2 to row 1. And that'll get rid of that negative 2. Okay? So, I'm going to do these bottom ones that are already right. So it's 0, 1, 0, and minus 1. Or, yeah. And then 0, 0, 1, 2. Those did not change, right?
Yes, sir.
So now what are we going to do? This one is going to be 1. Okay, so I've got the 1. Now I'm going to add 2 times row 2. So I have minus 2 plus 2,
0.
which is 0. And now I have 0,
Plus 2 times 0, which is 0.
0. And now we got to be careful on this one. We're almost done.
We have 3 plus negative 2.
3 plus negative 2,
So it's 1.
1. Okay. So now, if this, remember, is x, y, and z, we are done. X is equal to what?
1.
1. Y is equal to what?
Negative 1.
Negative 1. Z is equal to what?
2.
2. Right? Because it's 1 times x plus 0 times y plus 0 times z. X is equal to 1. Y is equal to negative 1. Z is equal to 2. Okay. So I think that I think it's easier to work your way back up than to do back substitution. Because it's like you're in this manipulating row mindset, and then you switch over and try to start doing algebra. And so I think that actually I like doing it better this way, because it seems like it's more work, but you're working matrix to get right to the answer. Okay, this is still in that same section. What section are we in?
8.1.
8.1. Chapter 8, section 1, and you're going to do 75, 76, you're going to do 81 through 84, okay? And now I'm going to give you, you can go ahead and stop it.